So today what we're talking about is scatter plots. What is a scatter plot and what do we use them for? Why do they call them scatter plots? It looks like a bunch of scattered points, like it just points all over the place, right? What do we use them for? Like what kinds of sets of data, Abby, do we use scatter plots for? Come on, what do you think? Okay. Yeah, I mean, we could go years and like species for a, but generally speaking, just any other idea, yeah. Huh? Okay. So we could ask the whole class, right? Or ask every freshman over the time that you were virtual, you know, how much TV time that they watched per day. And then we also look at their grades. Or how about we do missing assignments, right? Now, with this, what do each point represent? Like if I have a point right here, what does that point represent? It represents one specific person, right? This one specific person, what could you say about them? If the point was right here, what would you say about this particular person? What do they watch a lot of TV? Yeah. Are they high or low on the TV scale? Oh, they're low on the TV scale, but they are high on the missing work. So they must be doing something else with their time, right? Like they're not obviously doing their homework because they have a lot of missing assignments, but they're also not watching a lot of TV, so they must be doing something else. Maybe they have a job and they work a lot and whatever. For some reason they have a lot of missing assignments. If you have a point down here, what does that represent? They don't watch a lot of TV, but they also don't have a lot of missing assignments. So maybe they're spending their time basically just doing what? Doing their schoolwork. Okay. How about a person over there? Lots of TV, but not a lot of missing assignments. Maybe they can multitask and they can watch TV and do their work at the same time and that kind of thing. And then a person up here would be a lot of missing assignments and they watch a lot of TV, which kind of makes sense, right? So with scatter plots, what's the point of putting it? What would be the point of me asking all the freshmen a question like that and plotting that data? Because yeah, you would have points. Do you imagine that we would have points all over the place? Yeah. Sure we would. Would we have some points in all four corners basically? Sure we would. What would be the idea though of doing that scatter plot? What's that? Yeah, to basically see if there is what we call a correlation. What is a correlation? And this is an important topic in today's crazy world. What does the word correlation mean? Abby, what does it mean? Okay, it describes a relationship between two data sets. Does correlation, so in this case, would you imagine that if we did this over the whole freshman class, yes, there's going to be points in all four corners, okay? Is there going to be a relationship? Do you think there's going to be a trend that we see? What do you think? Why? would you imagine that we would see, in this case, if I did the same idea, where we went TV versus missing assignments, right? Do you think we would see a scatter plot that looks something like this, with, a couple up here, a couple down there? Or do you think it would look more like that? Or do you think it would look more like that? Which one of those three, we'll call it A, B, or C, what would your prediction be? So let's just do it by show of hands. Everybody's got to pick one. A, B, C. I'm asking the whole school. How they did over break, over the virtual time. How many think you would see kind of a trend of, yes, you'd see a couple up here, a couple down here, but you would see most people in this band here. Or, same thing, maybe a couple down here, a couple up here, but you'd see most people in this band here. Or do you think it would just be a pure scatter? How many think A? Everybody's got to pick one. I don't care who you vote for. Everybody's got to pick one. How many think A? How many think B? How many think C? Okay. Defend. Why do you pick C?
Because there's just so many kids that it could really be anything. And I don't think it would be perfectly going, not perfectly, but going up and down. I think it would be everywhere.
Okay. If we saw this, what would that say? What kind of correlation is this? This is a positive correlation. Okay? And what a positive correlation, and first of all, why is it positive? It's increasing, right? Now, what that means is little TV, little assignments. Lots of TV, lots of missing assignments, right? That kind of makes sense, doesn't it, to an extent? It's not going to be perfect, right? What about here? This trend means little TV, lots of missing assignments, lots of TV, little assignments. You think this is going to happen? Probably not. You're probably not going to see what we call a negative correlation. Why do we call that a negative correlation? It's going down, right? This would be what we consider no correlation, because there's no pattern at all, right? I could see some people saying, yeah, we'll probably see everybody all over the board and it's just pure random. I would bet we could find a relationship between missing assignments and something. Maybe it's not amount of time watching TV. What else do you think it could be? And guys, you'll find correlations with the weirdest things. You'll find correlations with missing assignments and weather. Temperature. We'll just put temperature. Now, does one, with a correlation, here's something I need you guys to understand. And this is absolutely critical in today's crazy world. Does correlation mean causation?
What?
Does correlation mean causation? Just because there's a correlation, does that mean one causes the other? No. That is absolutely not true. Just because you see a relationship happening where one works with the other, they might be both being caused by the same thing, right? Or there might be another factor that's influencing both of those data sets to work in the same way. You know, it might be, like if we did a correlation between missing assignments and test scores, is there going to be a correlation there? Is there going to be a relationship? Those who have a lot of missing assignments, what do you think their test scores are probably going to be? Low. You're probably going to have a bunch of points down here. Those who have very few missing assignments probably are going to do what? High test scores. Are you going to probably see a negative correlation here? Yes. In this case, is one causing the other pretty much? Yes. But I need you to understand, just because there's a correlation, just because you see data, and guys, think about all the data you're bombarded with on TV and on Facebook and on the internet, right? You're bombarded with charts and things work like this. Just because you see a relationship doesn't mean one is causing the other. That is an absolute fact. Now, sometimes is it true? Yes. But sometimes you might see how about year and gold medals at the Olympics for the U.S. U.S. gold medals. You might see a positive correlation. It might go down. It might be totally scattered. It could. It absolutely could go up and go back down. It would be a positive correlation up to a point, and then it would change to a negative correlation. It's not like it's going to be Now, is the year causing the medals?
Yeah, because the guys that won are getting older.
You just said something different. All right, you're saying the same people are getting older, so they're getting better? Is the year causing the number of medals to go up? No, there's other factors in play here. There might be different people. The training might be getting better. Like, there's so many different variables that could be causing the reason why the medals are going up. It's not that the calendar is getting bigger, right? It's not that the numbers in the calendar is getting higher. It's because there's other factors in play, right? You're not going to say that the number of medals are going up just because the year changed. You might argue the athletes are getting older, so they're more experienced, and you might argue that aspect of it. But then it would make more sense to have a different bottom line. Maybe the bottom line would be age of athletes, right? I need you guys to understand, especially when you look at data sets like this. If you see a relationship, it doesn't mean causation. It just means there's a correlation between the two. Okay? So, now, if you look, sometimes there's obvious positive correlations because you can basically say there's causation. We already know it's probably going to be caused. Like missing assignments and test scores. Yeah, we know there's going to be a negative correlation there. Because, people that have a lot of missing assignments, they typically test low because they haven't done the practice, right? And people that have a few missing assignments, they generally test higher because they've done the practice. Are there still going to be some people down here? Absolutely. There's people that are going to turn in all their homework and they're just not going to test very well for different reasons. Could have been they cheated on all their homework. It could have been they got help and they got their assignments done, but it just didn't quite click in their brain. They might have, other reasons, testing problems, whatever. They could just sit next to a kid that smells and I can't concentrate for whatever reason on the tests. Who knows? There are lots of reasons. There's also going to be a few people up here, right? But if you see what we call outliers, if we see people that don't fit the data, does that also mean the data is broken? No. Is there going to be exceptions to every single rule? Pretty much. There's always going to be exceptions to most rules. And just because you can find one or two examples that break that rule, that doesn't necessarily mean the rule is bad. Right? So, if you do look at page 262, that first one they're talking about there is the year versus species added to the list of endangered animals, right? What kind of correlation are you seeing there? Positive or negative? That's a negative correlation. Now, I'm not saying the year is causing the number of animals added to the endangered list going down. What do you think could be causing that? What are some real life reasons why the number of, we're just not adding, in 1996, we added 91 different types of species onto our endangered species list. And then in 2002, we only added 9. Why do you think we're not adding more and more species to that list? What could be some actual reasons why? So the overhunting is not happening as much anymore? Is basically kind of the idea? Okay, that could be. What are some other reasons? How about some simple reasons like they're already on the list? How many species are there? Well, there's a finite number. There's not an infinite number of species, is there? There's just not millions and millions and millions and millions and millions of different types of species. There's only a set amount, right? So once they're added, they can be taken off, but if they're added once a year, we don't add them again the next year and add them again and that, right? So that could just be that idea. It could just be that they're already on the list, so we're not going to keep adding them. But yeah, there's other reasons. Environmental protections, and we're taking care of their land better and whatever. We're more conscious of it. So there's reasons for it. Does everybody understand the simple idea of positive, negative, and no correlation? That's easy. And sometimes you can predict it. Most of the time you can predict it if I give you a relationship. But sometimes you would think there's absolutely no correlation. Two things that have absolutely nothing to do with each other. And you'll see a correlation. And you'll say, why is there a correlation? And that sometimes is an interesting question. Why is there a correlation between two things that just seem to have nothing to do with each other? You could do a correlation between shoe size and GPA. Are those two things, should they have anything to do with each other? Maybe you would see a negative correlation. I'll bet you if we did, it would look like that. I'll bet you we'd see a positive correlation. Or, no, I'll bet it's negative. Now that I think about it, I'll bet you the smaller your shoe size, the higher your GPA.
Very much.
So now, is there going to be exceptions to the rule? Are there going to be some big-footed people that have a high GPA? Yep. Is there going to be some really small feet that have low GPA? Yep. But I'll bet you'll see a slight negative correlation between the two. Should they have anything to do with each other? Absolutely not. Should have nothing to do with each other, right? Why do you think there might be a correlation there? I'll tell you why there is.
Because other people are smart.
No, because girls have a higher GPA than boys. It's not because of shoe size, right? But you'll look at a graph and go, there's a correlation here. The problem people make is they look at the data and they go, ooh, there's a relationship there. This must cause that. Does this cause that? Absolutely not. There's other reasons that are basically affecting both of them, right? There's other influences that affect both of them. But if you graph them together, you'll see a relationship there, right? Now, here's where it gets interesting, and here's where, Abby, I need you to pay attention with this. Once you see a relationship, we can draw and we can calculate what are called trend lines. Okay? A trend line, another word for that, is what we call that is a line of best fit. What do you think a definition of a line of best fit is? But I can't draw a line through all the points.
Well, yeah, but like, you draw the line, and it's just like an average.
It's kind of like an average line. It really is. It's not, technically it's not an average line, but basically, here's what a line of best fit is. If I said, draw a line, not trying to connect a single dot, but you're trying to draw one line that represents that data, that goes through the middle of the data as best you can. You can't connect all the dots, right? But you can do as good of a job as you can with that. Does the line of best fit actually have to go through a single point? No, it doesn't have to hit any of those points. Hopefully it hits some of them, but it doesn't have to. Now, if you see a line of best fit or a trend line of what we call those, what can we use that for? Let's say we did this one, year and gold medal, and I said draw a line of best fit. Be roughly like that, yes? Everybody agree? What could I use that line for? Well, show how close the data is. But what if I wanted this point? Let's say this is 2020. I'm going to look at 2030. 2030 hasn't happened yet. What can I use the trend line or the line of best fit to do? I can get an approximate answer. Now, is that answer that I get going to be very specific and it's definitely going to be that number? No. All it's going to do is give us, I'll bet you we're in that ballpark. As long as these trends continue. And now, could the trends change? Yeah, something dramatic could happen, right? And all of a sudden, the trend changes. But as long as things keep going the way they're going, I can have a reasonable number of what to expect in the future. Okay? And that's really the best use for trend lines or line of best fits. All right, everybody look at the bottom of page 263. See where it says example 3? I want you to tell me what type of correlation would you expect? Okay? In letter A, the number of empty seats in a classroom, this classroom has a lot, and the number of students seated in the classroom. So basically, empty seats versus filled seats. Positive or negative correlation? Good, that's an easy one.
Right, it goes up the other way. Our class is down low.
If we went through the whole building and charted, all right, this class has 18 empty seats, so a lot of empty seats, and only 12 filled seats. So, right? And then you go across the hall, and they have 25 filled seats, but they only have 8 empty seats. What kind of relationship is this going to be? That's got to be a negative relationship, right? Because if you fill one more seat, well, now you have one more or one less empty seat. That's definitely a negative correlation. As one goes up, the other is going to go down. In a negative correlation, that's exactly what you should be thinking. If one number goes up, the other number will go down. A positive correlation, if one goes up, the other goes up. In a positive correlation, they go together. They either both go up or they both go down. That's a positive correlation. A negative correlation, if one goes up, the other goes down. Does that make sense? And a no correlation means, yeah, I would expect there not to be a relationship at all. It's going to be totally scattered all over the place. Okay? How about B? The number of pets a person owns and the number of books that person reads. Positive, negative, or no? You'd say positive, so if they have a lot of pets, they read a lot?
Yeah, because you never know. Because if you're sick, you couldn't have to read them.
Huh? Mac, what do you think? You'd say no correlation? You say no correlation? I'd probably agree. There probably isn't much of a correlation. Yeah. So, all right, turn the page. Now, I want you to look at example 5, that fundraising application one over there. Okay? Now, again, the data is moving up. Okay? That's definitely a positive correlation. They drew that line of best fit. If I said I wanted you to predict, just use that data, guys. If I said I wanted you to predict, just use that data. Tell me how high you think that line is going to be at 250 rolls sold. It's not even on the graph. 250. How high do you think that's going to be? What's your prediction? 250 is what my guess. That's what I want you to predict. 250. It only goes to 200 right now, right? How high is it at 200? About 1,200, a little higher, maybe, baby. So what do you think about 250? What do you think, Mac? Yeah, probably about 1,400, maybe 1,500, right? Somewhere in that range. But we can use that line of best fit, or that trend line, to predict the future. Okay? All right. Yeah, everybody just turn to page 266. I was going to show you actually how to calculate those trend lines, like come up with the equation, but maybe I'll do that on Tuesday. All right, most of this stuff I think should be pretty easy. Number one, guided practice. Give an example of a graph that is not a scatter plot. What are some other types of graphs? Not scatter plots. Bar graphs. Line graph. Pie graphs. Huh? Like, there's lots of them, right? Number 3. Does a trend line always pass through every single point in a scatter plot?
No.
Does it have to go through any? No. It just goes through kind of the middle of all the data, right? Tries to represent the data as best it can. Number 4, draw a scatter plot. Does anybody need help doing that? Pretty easy. Yep, just have plots everywhere. Number 5, is that a positive, negative, or no correlation? I'd say that's positive. How about 6? That's negative. All right. Number 7, would you expect? None. The volume of the water poured in a container, the amount of empty space left in that container. That's negative, because as the water goes up, empty space goes down. How about 8? A person's shoe size and the length of the person's hair. What do you think, Em? You'd say no? What do you think? Negative? Yeah. You think negative? So, as people's hairs, or the feet get bigger, they have less hair? I actually might agree with you a little bit. Why? Why would you say there's a negative correlation? Generally speaking, I would agree with you. For one reason. Who has longer hair, generally? Girls. Girls have smaller feet. For that reason and that reason only, I would think there might be a slight negative correlation because girls have longer hair, generally. Are there exceptions to every rule? Yes. There's some girls with really short hair with big feet. There's some boys with... to say. All right. How about number 9, the outside temperature and the number of people at the beach? As the temp goes up, there's more people at the beach, right? That's a positive correlation. Now, again, I do want to stress this idea to you. Does correlation mean causation? No. Just because there's a relationship, it may or may not mean that one thing causes the other. Yes. Would temperature cause the number of people to go to the beach? Kinda, because they want to cool off, right? Like that probably is a real causation type of thing. And yeah, if it's freezing outside, no one goes to the beach because it's way too cold. Like that's a definite causation there. But just because you see a correlation doesn't mean causation. Like the hair in the feet, right? If we say there's a negative correlation between shoe size and hair, does that mean causation? Does someone's hair getting longer mean their feet shrink? No. It just happens to be that we see a relationship when we graph them together. Okay? All right, that's all I got for the day. So, you